Hi guys, thanks for coming back again. If you have been a subscriber and if you're new here, endeavor to click on the subscribe button and turn on the notification bell. That will let you know when we drop a new video. Yeah, we want to discuss friction here. Friction, which is part of the topic you might come across in some O-level exams, UTME, and all O-level exams, or even A-levels. So the topic is friction. Friction, or you call it frictional force. So what is friction or frictional force? This is a force that opposes motion. So, and it's a force that exists between two surfaces that are in contact. For instance, your feet on the floor, the force that exists between your feet and the floor is friction. So, and then friction only acts on rough surfaces. So when a surface is frictionless, that means the surface is smooth. So that is there is no friction or low coefficient of friction. So now we want to talk about the two types of frictional force. So which means frictional force or friction is divided into two parts. We have the static friction. This static friction can also be called limiting friction. Then we have the kinetic friction, which you can also call dynamic friction. So what is static friction? Static friction is the frictional force that must be overcome before a body begins to move. So this simply interprets that static friction is the frictional force that keeps two surfaces in contact and stationary. So it is static friction. So for the body to slide or move over each other by pushing one of it, for instance, placing a wooden block on the table. So the wooden block is on the table and is stationary because there is static friction, though not only static friction that is present there that makes the body stationary. However, in process of sliding the body, static friction is the only friction that could keep the body stationary. Then, so this force must be overcome before the body begins to move. So that is static or limiting friction. Now, kinetic friction is the frictional force that exists when between the two surfaces when they are already in relative motion. For instance, when you are already sliding a wooden block on the table, so the limiting friction has been converted to kinetic friction, and this kinetic friction, the function is to now stop the body that is already moving. So a car moving on the road now, you understand, uh, is likely to, I mean, before the car begins to move, it exists static friction between the tires of the car and the floor and the ground. So then when the car begins to move, then we have kinetic friction trying to stop the moving car. So that is kinetic friction. So that is what friction is all about in terms of definition. And take note, friction only takes place on rough surfaces and not smooth surfaces. When you have a smooth surface, it means that frictional force is not there and the surface is frictionless, or friction is very small. So now let's talk about the static friction in detail using the scenario of a wooden block on the table. Static friction. So in order to understand the concept of static friction, so let us try to draw a wooden block on a table. So let's say for instance this is the table, and then you have a wooden block on that table. So let's change the color so that we can make a difference. So this is the wooden block on the table. So now it is stationary. So before we talk about the frictional force in detail, let us consider the other forces that are on this table. Now, one thing you need to understand is this body resting on the table is stationary because the algebraic sum of all the forces acting on it is 0. So when all forces acting on a body add up to 0, the body will definitely be at equilibrium, which is stationary. Good. So we're going to talk about the first force, that is the weight of the body. The weight of this body acts downward in this direction. So that is a weight W. It acts downward in that direction. Now, according to Newton's law of motion, the third law of motion, that states that for every action there must be an equal and opposite reaction. So the action of the weight of this wooden block on the table is W. Meanwhile, the table must be able to give an equal and opposite reaction. So which will always be opposite. So which means the reaction of the table on the wooden block is gonna be in opposite direction. It's gonna be in opposite direction. So let us try to explain that. Though they would be equal in magnitude, but they would be in opposite direction. So that's it. So the weight of the body is acting downward, while the reaction of the table is acting upward. So these two forces balances each other. So the one that acts upward, so let's call it R, which you can call the normal reaction or normal force. So normal reaction R, so that is it. And apart from that, there is a frictional force existing between the table and the block. So that frictional force is static frictional force or limiting friction that is holding this body. So which means we have three forces: the weight of the body, the normal reaction, which is also equals to the weight, and then the frictional force that act in direction oppositing the motion of that block. So if I try to move the block towards the right direction like this, okay, no, if I try to move this block like this, frictional force is going to act in opposite direction to that, so which we are still going to analyze with arrows. So now we must understand that the weight of a body W is equals to the mass of the body times acceleration due to gravity. So which means the normal reaction is also mass times acceleration due to gravity. You have the reason to watch this video to the end because we have a lot of things to touch on the friction, so you would not like to miss any part of it. So this video will start from elementary and hit every aspect that you need to know as you are preparing for your exams. So now that is frictional force. I mean, that is the two forces acting in opposite direction on that body. Yeah. So now, let us now consider the frictional force when uh, someone is trying to push the table. So if we have to push this table, I mean the block on the table, we must overcome the static frictional force. So there should be a static frictional force acting in this direction. Oh no, there should be a static frictional force acting in this direction. Yeah, if there is a pulling force acting in this direction. So this is it. Good. So this is frictional force Fr. That is frictional force Fr, F subscript R. So and this is pulling force. Let's call it force P. So we are going to analyze different things about these forces. Now, one thing you need to understand is if you want to pull this body, it depends on the mass of that body. However, also the frictional force acting between the surfaces depends on the weight of the body. So which means the bigger the weight, the larger the frictional force existing between the surface and the table. Table surface and the block. So the bigger the force, the frictional force, the bigger the mass. And when the mass is big, what happens? We are talking about the normal reaction. So if if a bag of rice is resting on the table, the reaction will be different from when a piece of paper or an exercise book is resting on the table. So which means the frictional force Fr, F subscript R, is proportional to the normal reaction. So which means the bigger the normal reaction, the bigger the frictional force. So here we're going to introduce a constant. So the frictional force will be, then the constant will be coefficient of static friction, multiplied by the normal reaction. So which simply means coefficient of static friction is equal to the frictional force over normal reaction. So that is the case. So this is what we have as far as the block and table is concerned. So we have the coefficient of friction to be force over normal reaction. Now normal reaction and frictional force are measured in Newton because normal reaction is a force and frictional force is also a force. So which means coefficient of static friction has no unit. It has no unit. So that is it. So this is just one part we need to fulfill and the basic part of it. Now this is when you are trying to slide the body horizontally. If force P is equal to frictional force, so it is obvious that the body will be still stationary because two opposite forces are equal and they are balancing each other. So the body will remain stationary. So now in a situation whereby the force P applied overcomes the frictional force and is greater than the frictional force, that means there would be an acceleration of the block. So we can calculate the acceleration of the block using the extra force applied F equals MA. Now, what is the extra force that is applied? How do you get it? You know, part of the force P applied, if it is greater than the frictional force, obviously, and it's going to give the block an acceleration. So this is one formula you should note. Okay, let's put this as 1. So then we're talking about when you apply force P, which is far greater than the frictional force, and it gives the block an acceleration. So the force F would be mass times acceleration. So this force F should be equals to P minus frictional force. So in that wise, in such case, you're going to be having force P minus the frictional force to give you mass times acceleration of the body. So this is another concept of formula you need to put in place. So let's say this is 2. So that is it. Based on, you might find question that asks all this. So now let's look at another aspect. There are situations whereby you try to tie a rope to the block, probably it's heavy and you are dragging it. So this case now, it might not be on the table, it might be on the floor. So you are trying to tie a rope to the wooden block and drag it. By the time you drag it, you can lift it up a bit and then drag. So now let's look at the diagram to explain that. Okay, let me use the same diagram. So now for this, so let us draw a line to represent the horizontal ground. So let's look at that. So this is the horizontal floor. So and we tend to drive this body using a particular force P in this direction. Yeah. So now this force, we tend to lift the body up a bit. So now we want to drag this body with force P. So this is the force P trying to drag this body. Now one thing about this force is that, don't forget, you would have the mass of this block. So now let us look at the angle which the force P is acting. So if we consider the angle force P is acting, so we can just consider that angle in this direction. So let this be angle theta. So let this be angle theta. So now good, the force P is acting at angle theta. So what other thing do you think will be involved in this diagram? We're going to have the normal reaction of the body, the weight, and the likes. Now this force P will have two dimensions. Yeah, because we're going to have the vertical component of the force, which will act like this. Yeah. And we're going to have the horizontal component of the force, which will act like this. The horizontal component will act like this. That is how it's going to act. So these vertical components and horizontal components, so this would be px, and we're going to have the py. Now to calculate px and py, we use the resolution of forces formula. So the vertical component of the force py could be calculated using p sine theta, and the horizontal component could be calculated using px equals p cos theta. So now let us analyze straight away. You would see that the horizontal component is acting parallel to the plane. So just like frictional force, we act in opposite direction. So the frictional force will act also parallel to the plane in this direction. The frictional force will also act like this. Yeah. So this would be the frictional force, which is now opposing the motion of the object on the ground. Now, the normal reaction will also be there if you look at the normal reaction. So, because trying to pull it with force P might tend to raise the object upward a bit because of the vertical component of the force Py. Because when you tie the rope and then you drag it with force P, you are moving it forward, and moving it forward is with force Px. Now you can raise it up a little bit with force Py. That is it. So then this force Py, definitely you have your normal reaction in this direction. You have your normal reaction here. and the weight of the body as well in this direction. But now look at it, the weight of the body is now divided into uh, two parts, because part of the weight has gone with the uh, normal reaction, and part of the weight has been lifted up with py. Okay, what I'm saying in essence is that if you try to drag it with force p, you discover that you lift the object up a little bit with part of the force p, which is py, and you drag it horizontally with px. So good. Now the normal reaction will be there because part of the block, despite the fact you are raising it a bit, part of the block is resting on the ground. So that is still the normal reaction. So there will be a normal reaction for that. Now the weight of the block now has been splitted. So part of it resting on the ground is equivalent to normal reaction. Then the remaining part has been lifted up using force py. So which means the weight of the body now would be the sum of what? Py plus, that will be py plus the normal reaction. So looking at this, we have py plus normal reaction. Then the frictional force would be equals to the force horizontal, that is px. So you'll be having px equals to frictional force. Mind you, from the coefficient of friction equals force over normal reaction, the frictional force will be coefficient of friction times normal reaction. So then px would be coefficient of friction multiplied by the normal reaction. So this is another analysis based on that. So now don't forget py is p sine theta, so which means w would be p sine theta plus r. Meanwhile, you're gonna have px, which is p cos theta equals coefficient of friction times normal reaction. So this is the formula that is pertaining to when you are trying to drag this block with a rope. So we're still gonna solve question on all this. So now we have been talking about static friction when the object is placed on horizontal plane. Now let us assume the table is now inclined. So that is the object placed on inclined plane. So what would happen, or what would be the situation by then? So now let's go straight to that. So now this is an inclined plane. So this plane is inclined. Yeah, this is an inclined plane. So the plane is inclined at a particular angle, theta. So let the angle of inclination be theta. So now if an object is placed on this plane, okay, let's look at drawing the object. Okay, So now let's look at these objects placed on the inclined plane. So what will be the situation of this object now? So apparently you would see that the objects will tend to slide down. It's going to slide down. Now in this case, don't forget when we were talking about when you place the object on horizontal plane, the weight of the body is acting directly downward. But this case now, the weight of the body will now be two-dimension because part of it would be used on the inclined plane. Part of it will act like this. Part of it will act in this direction. That's part of the weight. We go this way. And the other part goes this way. So the other part of the weight acts parallel to the plane. So which means the weight itself is acting as a resultant in this direction. So this is the weight W. So it has been splitted into two parts, which is W in this direction and W in this direction. So we call this the vertical part of the weight, and this one is horizontal part of the weight. Or let's say this one is parallel. Let's put it parallel to the plane, while this one is okay, parallel to the plane, and this would be perpendicular, PD, to the plane. So now the one that is parallel to the plane, we have the value W cos theta. I mean the one that is perpendicular to the plane, we have W cos theta. So why the one that is parallel to the plane will now be W sine theta. This is so because you are actually taking the body through an height downward. So which force is responsible for taking it downward? It is the W sine theta. So taking it downward is more or less like traveling this height downward vertically. So we're going to represent it with the vertical component of force. So that is why the one that is parallel to the plane is W sine theta. So why the one that is directly downward, acting downward, is W cos theta. So then the normal reactions still apply here. So the normal reaction of the plane, would be equal to not the whole weight again. It will now be equal to the one that acts perpendicular to the plane. So it's gonna be like this. So this is how the diagram seems to look like. So this is normal reaction R. So the normal reaction R would be equals to the force that is perpendicular to the plane. So the force that acts downward, don't forget that normal reaction will act in opposite to the force directly acting on the plane. So when the object was placed horizontally on the plane without on a horizontal plane, the weight was acting directly downward, so normal reaction is against it, and then they balance each other. So but in this case now, the weight is splitted into two parts. We have the W sine theta, which is dragging the objects downward, and W cos theta, which is vertically acting on the plane. So the normal reaction will definitely be equals to the one that is vertically acting on the plane. So R equals W cos theta. R is W cos theta. Now, so the force that is dragging the object down the plane would be what? W sine theta. In this case, we'll talk about frictional force acting in opposite direction. The frictional force, this is now kinetic friction, because the kinetic friction will try to stop the body. So the kinetic friction will be acting in opposite direction to the plane. So that is it. Now, how do we find the value of coefficient of friction here? To find the value of coefficient of friction, we say coefficient of friction is the force. Now this situation, now you have force, the frictional force acting in opposite direction, to be equals to W sine theta. So we have a frictional force Fr here, which is equals to W sine theta. So then we can say W sine theta. Okay, let's use, okay, that's the frictional force. The coefficient of friction now is the frictional force W sine theta all over W cos theta. So this goes with this. So coefficient of friction would be sine theta over cos theta, so which is what? Tan theta. So you can automatically just find tan theta to know the value of coefficient of friction. Now, there are cases we need to talk about as far as this is concerned. Now, suppose this object is moving downward. We'll say W sine theta is equals to the frictional force, and that is how we got our coefficient of friction to be tan theta. Now, how about the situation where I want to make the body stationary despite being on an inclined plane? I want to make it stationary. I want to add an extra force to make the object stationary. So how do I go about that? So what I need to do is I need to calculate the extra force that I need to add to that body to make it stationary. So in order to make the body stationary, so how do I make uh, the force? How do I add an extra force in the direction of the frictional force to keep the body stationary? So now, one thing we need to know is that the force that will keep the body stationary is always the difference between W sine theta and the frictional force. Yeah. So if we say the frictional force, now this is body sliding down and I want to keep it stationary without moving at all despite being on an inclined plane. So that is the case 1 we're meant to talk about now. Case 1. So the first case is case 1. So making the body stationary is the case 1. So now to make this body stationary, I must add an extra force. So one thing you need to understand is that this frictional force is relatively small to W sine theta. So in order to find the extra force that I'm going to add to make the body stationary, I only need to know the difference between the W sine theta and the frictional force. So for the body to be stationary, for the body to be stationary, I must apply a force P, which is equal to W sine theta minus Fr, which is frictional force. Now, don't forget, we can have W sine theta, y frictional force is coefficient of friction times normal reaction. So then the force P I would apply would be W sine theta minus coefficient of friction times W cos theta. Don't forget W cos theta. Don't forget the normal reaction is W cos theta. So in this case now, if I want to make the body stationary, I will just need to add a force P in the direction of the frictional force, which would be the difference between W sine theta and F, which is the frictional force. So the bedrock of this is that the frictional force acting in this direction, that is this force here, it is very small compared to the force acting here, that is sliding the body down. So in order to make the object stationary, I need to add an extra force to the frictional force in this direction, and the extra force I'm adding, if you add it up with the frictional force, it should be equal to W sine theta. So which means automatically, if I bring this extra force, if I bring my frictional force to this side, so which means my W sine theta would be P plus frictional force, which is coefficient of friction, times W cos theta. So which means in the first place, the frictional force is less than the force sliding the body down. And then in order to keep the body stationary, I must add an extra force to the frictional force, which will balance W sine theta. So then the body will be stationary. That is case one. Another case is if I want to drive the body up the plane. Now, the case of this, the first case is when the body is sliding down. Okay, so if the body is sliding down, you would see that W sine theta is greater than the frictional force in opposite direction. And then to make it stationary, you add an extra force to the frictional force, which will balance W sine theta. So now in this case, in the second case now, in the second case, that is case 2, we want the body to descend, ascend. So ascending is the body moving up the plane. The body moving up the plane. So the condition that must be satisfied when the body moves up the plane now is if the body is moving up the plane, frictional force will not act in this direction again. Frictional force will not act in this direction again because the body is moving up the plane. It will then act in the same direction as the force bringing the object down. It will act in the same direction as the force bringing the object down. So frictional force then will act like this. Frictional force will act like this. So in this case now we have two forces acting if the body is meant to ascend. So frictional force begins to act in this direction. So this is frictional force Fr, and then the frictional force is now acting opposite to the force that is dragging it up. Don't forget we said friction is always opposing motion. So if we are trying to drag the body to the extent that it ascends the plane, it moves up the plane, so frictional force will automatically be opposite the motion. Meanwhile, this force, which is W sine theta, is still acting downward the plane, and now frictional force is adding up to it in order to drive down the plane. So in order to make the object move up the plane, the magnitude of force that you need to add, let's say the force is force P. So you need to add a force P, and this force must contain both the frictional force and the W sine theta, so the body can ascend the plane. So which means in order to move the body up the plane, you need a force P, that's case 2, moving the body up the plane. Moving the body up the plane, moving the body up the plane, that is a case of ascending. What must happen? We must apply a force P, which is equals to the sum of the frictional force plus the W sine theta. So don't forget the value of the frictional force now. The value of the frictional force is W, coefficient of friction, times W cos theta. So we have P equals coefficient of friction times W cos theta plus W sine theta. So this is the two cases. Okay, we have talked about the the first cases where we want to make the body stationary, then the second case where we want the body to drive up the plane, then okay, the third case is when the body is sliding down, and that is automatically what is going on here. So the W sine theta is the force bringing it down, and the friction will act in opposite direction. So this is brief explanation. So we have other part of it which we cannot conclude in this video. The only part we are moving to now is to solve two questions. So the two questions will help us understand this particular part, and then uh, expatiate more on maybe one of the previous parts we have discussed. So any other fraction of this topic that has not been touched in this video, we are gonna make another video to cover it. So now let's look at a question. I'm gonna put a question here so that we can all get it. So now, like, we have a concrete block of mass 25 kg is placed on a wooden plank inclined at an angle 32 degrees to the horizontal. Calculate the force parallel to the plane that, number 1, keep the block at rest, then 2, make the object begins to move off, provided we are given coefficient of friction has 0.45 and acceleration due to gravity is 10 meters per second squared. So let's take the question again. When the concrete, okay, the concrete is, I'm going to use the same diagram here to explain it. So we said the concrete block has the mass m, which is 25 kg. M is 25 kg. Secondly, we were told that the block is placed on a plane inclined at 32 degree. Then we are also told that we need to calculate, okay, we also told that coefficient of friction is 0.45. Then what next? We're told to calculate the force parallel to the plane that will keep the body stationary. So which means this is question on case 1. The question on case 1. So to make the body stationary, we are actually looking for force P to keep the body stationary. So what we're going to do is very clear. So we just find our W sine theta, which is the force driving the object downward. So W sine theta would be equals to, and W is mass times acceleration due to gravity, so which means we're going to be having 25 times 10, so that is 25 times 10 multiplied by sine 32. So and that gives us sine 32 is 0.53, so which means we're going to be having, okay, we have W sine theta equals 25 times 10 times 0.53. So automatically the answer is giving us 132.48 Newton. So this is it. So now then we need to calculate the frictional force. Don't forget the frictional force Fr is coefficient of friction multiplied by cos theta. So coefficient of friction, that's this, multiplied by W cos theta, and that is 0.45 times W is 250, which is 25 times 10, multiplied by then cos 32 is altogether we're going to have times cos 32 rather. So putting all this together, the frictional force Fr is equals to 95.41 Newton. So which means the force that would balance the object is going to be P equals 132.48 minus 95.41. So at the end of the day, the force becomes what? 37.07 Newton. So this is a typical example of how to apply the first case. Now the second case, let's go to the second case now. Let's look at a question on second case. So for the second case, you are meant to calculate the force that will be able to take this object up. So let's take, for instance, you want to calculate the force that will be required to take the same object with 25 kg. You want to calculate the force that will be able to take it up. So all you need to do is you have calculated your frictional force. So the force that will be able to take it up, P, would be according to this formula here. So we're gonna find our W sine theta, which we have done already. That is 132.48 plus the frictional force, which we calculated to be 95.41. So for it to move up the plane, you just have to add this force together. So adding them together, you will be having 227.89 Newton. This would be the situation for the second case. So this would be the force required to drive the object up the plane, and the force required to make the body stationary will be 37.01. So this is what we have for us on frictional force. Thanks for watching. Please subscribe to the channel and endeavor to share our video and give a good comment. Thank you.